Good morning, ladies and gentlemen. Welcome back. Today is Monday, March the 1st. And again, what we're going to do is look at how quadratics from vertex form is transformed. And the idea is to go from the parent function, which is y equals x squared. If you don't remember what y equals x squared, you can pause the video and look at one of our previous videos about it. But y equals x squared in a nutshell is, when you use a table of values, -2, -1, 0, 1, and 2 for the x values. And for y values, it's 4, 1, 0, 1, 4. It definitely opens up, and I don't know if it's on the screen. It's really small over here. No, it's off the screen. Some of you can't see. I'll just swing this over just so that the people can see it in yellow. The vertex is 0, 0. It opens up, and it looks normal. Now, what I'm going to be using, although the handout talks about y equals a times x minus p squared plus q, I'm going to go and how it was taught to you in grade 10. And I'm going to talk about what a, h, and k in the context of transformations or graphing means. So hopefully this makes a little sense to some of you. Some of you actually were taught k first, then h, and then a. But I'm just going to go in the way that the letters are laid out, a, h, and k in the order. And the reason why is that h and k are the easiest to understand what's happening, and then a is the hardest. That's how it was taught in grade 10, or how I would teach it. But what is a? A stands for the vertical stretch or compression. Now, if you don't remember, in grade 10, really a lot of you know that a talks about orientation and shape. So a lot of you already know what orientation means. When a is greater than 0, meaning it's positive, you already know the parabola opens up. So there's no change to the parabola, right? So that's nothing. But when a is less than 0, meaning it's negative, a lot of you know it means it opens down. In the context of transformations though, although the parabola opens down, it really means a reflection across the x-axis. Okay? So that's what orientation means. Either opens up, opens down. It doesn't open to the side. These are not parabolas. They open to the left or the right. We'll talk more about that in a moment. Shape for a is a little different. Shape, when a is greater than 1, a lot of you actually know this means a vertical stretch. What's a vertical stretch? That means it's going to be narrower. So I'm just using some colloquial words that a lot of you actually noticed from grade 10. How about when a is in between 1 and 0, like a fraction between 0 and 1? If it's between 0 and 1, you know this as a vertical compression. And it really means it gets wider. I don't like using the word fat. So some of you actually understand what happens if a does equal 1. When a does equal 1, just like in our y equals x squared, it's considered normal, or the standard or base parabola. That's why y equals x squared is the famous one, and that's why in this question, ladies and gentlemen, we're always going from the parent, or the base function. So we're going to describe what's going to occur. Notice a is kind of weird because it gives us 2 components, and some teachers teach them all at once. I like breaking it down to its parts. Not all of them are going to happen like this, and we'll talk more about it in a moment. But that's the vertical stretch and compression. That's what a stands for. H, and I may have to write it down. So this is the vertical stretch and compression. Vertical stretch and compression. H, let's put a line in here. H is the horizontal shifting left and right. The horizontal shift. And I still like helping students because some students get confused. So when they see x minus h, this means a shift right, notice the other direction. How many units? Plus h units. And if you see x plus h, it means a shift left. These are actually called translations, right? And we'll talk about that in a moment. So that's easy. Again, it's kind of weird because it's in brackets. Finally, the k. What does the k stand for? Vertical translations. And it's just easier, shorter to use vertical shift. So when you see plus k and minus k, the plus k means shift up, and the minus k is shift down. Plus k units. Minus k units. I know it's kind of weird, ladies and gentlemen, when you're learning this, because When we taught it, I think, in grade 10, maybe it's a different order. Maybe we didn't teach this first. We just taught you, can you find out what the coordinates of the vertex are? And that's kind of just giving you the answer, which is great, But what I'm going to show you is actually how to transform this y equals -2 times x plus 4 all squared plus 1 from here. So going from this to this. And what you're supposed to do first is you're always supposed to do the stretches or compressions first, then the shifts second. So hopefully we're going to follow along. I'm going to graph in blue the y equals x squared. Now if you have to pause the video, get some graph paper, that's fine. I have a chart on here that I'm going to do it by hand. I don't like using technology because technology, you can kind of just cheat and just graph that answer. This is actually, again, for just to let the class kind of get some time if they're sketching it out. And don't feel bad if you don't have graph paper, classmates here. This is how actually animation used to be done by hand. Some of you might have seen some of the artwork in the cells of Disney or cartoons and everything. They used to just draw them over and over and over again. This is actually what we're talking about. This is actually also the connection to what you're doing now with your smartphones, with your technology, with Snapchat or Instagram, putting filters on. It's actually this, albeit this is the math part, and it's kind of neat. So let's graph y equals x squared, and hopefully, if someone needs to slow me down, feel free to. I tend to take the 5 critical points, and I'm just really looking at that transformation. So that's y equals x squared. Hopefully this is going to be on there. Hopefully that's a blue. Let me just check the screen. No, I'll just move this slightly over. And hopefully that question's there. So what's the first thing that we see? We see an a value, and it's -2. And it tells me a lot of things. First of all, the negative means a reflection across the x-axis. So this blue graph is going to clearly be opening down, but reflect. So a lot of you intuitively know what's going to happen. Watch what I'm going to do slowly. I'll use red chalk. And don't get me wrong, I know I've only dealt with the orientation. So in the red chalk, this is y is equal to -x squared. So I'll just annotate so that everyone can see the colors. Negative, everyone see that? Now what to do with that 2? The 2 is related to the shape. And clearly the 2 is not equal to 1 or is not in between 0 and 1. Between 0 and 1, a lot of you understand that this is a fraction or a small decimal, right? So I decided to use a nice number of 2. So it means it's a vertical stretch, but some people don't know what to do. It's going to stretch by a factor of 2, so it's going to get nice and longer. So in orange chalk, we're going to graph y equals -2x squared. So 0, 0 still stays the same, and this 1 and -1, it gets stretched. So notice nothing happened to this one. We'll explain that more. It's called an invariant point, but it goes down to there and to there. So it looks like I'm moving. I'm not. I'm actually stretching. Very, very skinny. So this -4, well, some students have a difficulty understanding, but notice it's a factor. A factor means to multiply. What's -4 times 2? So -4 times 2 is -8. And why is it so easy for me to do it is because these parabolas are symmetrical. So let's just pause for a second. Not to pause the video, but let's take a look. And what you're doing is comparing the red parabola with the orange parabola. And even if you're not doing it with me in class, at least you can see it. It's clearly skinnier, right? It is narrower than the red parabola. Both are opening down. And I think a lot of you understand what we just did. So that's the 2 here. Let's see if someone can help out in the class then. Notice we do all the stretches first. Now what to do with this x plus 4 squared plus 1. Again, we're not really doing any math here. We're just interpreting what this means. Can someone help me out from the class? Which direction should this orange parabola go? And again, you have a 50-50 chance. Should it shift right or should it shift left? And if you need some help, look here. Clear? Shift left, and it will shift left 4 units. So we're going to take that orange parabola, and I will use yellow if that's okay. And shift everything 4 units. Now notice this is painful, but don't panic. Assuming that you've used a grid, it's easy. If you haven't, that's okay, ladies and gentlemen. We're going to take that 0, 0 and shift it 4 units. So the new point's going to be there. That's the new vertex. This one's going to shift 4 over. This is going to shift 4 unit over. This is going to shift 4u over, and this is also going to shift 4 over. And so we get a congruent parabola, and I know it looks a little messy, and I apologize, but this yellow parabola should be the same as the orange, except it's just in a different location. So we went from the we went from the orange to the yellow, and it went left. Now don't get me wrong, some students are asking, what? This method I'm showing you, notice I'm not even doing any calculations really. I just did one easy one at the beginning. So this transformation method, Mr. Petal actually teaches, and that's actually enforces, whereas I tend to actually teach you, just give me the answer. We're not done yet. The last one, I'm sorry, you should put that yellow spot there. So that's plus 4, plus 4. I'll erase the X. Our last color, hopefully the green will come out, is this plus 1. So I think a lot of you know what that means. We're going to take that yellow parabola and shift everything up 1 unit. And again, this one's long, but some of you are going to appreciate this a bit more. And I know it looks ugly. I apologize, ladies and gentlemen, for the class, but a lot of you know what I'm doing. The green parabola, the yellow parabola, and the orange parabola, they all look the same. They all should look the same. And the word that we use is called congruent, except they're just in a different spot. And some students ask, Mr. Chen, why didn't you take the orange parabola and shift it up first and then shift left? You could have done that too. But most students, when they see the question, just like reading a book, we tend to read from left to right. Notice what we didn't do? We did not do the shifts first. We did the stretches or reflections first, then the shifts second. Always this order, and we'll reinforce this when we get to our transformation lesson. So if you have to pause the video how I drew it, and I actually was graphing, even though this lesson is not on graphing, it's really the idea from the blue, then reflect, then stretch. Now, again, some students say, could you stretch the blue one first? Absolutely. I could have made the blue one, the red one, I could have made the red one skinnier and then reflected. But most students kind of go in the order that I just did for this question. The hard part was though the stretch part, which is a factor of 2. But I think a lot of you can do simple multiplication of 4 times 2, 1 times 2, 0 times 2, 1 times 2, 4 times 2, which is those answers there. Any questions from the class before I pause the video?